The research challenge that my project addresses is the lack of specific guidelines for aviation applications in both the mid-latitudes and the tropics. Turbulence prediction, it's a well-known issue, especially obviously aviation, and the approaches on how to study it have varied between idealized modeling, where we just try to understand what's actually happening, to statistical analysis, where we say, okay, what's the best approach at even just forecasting it? So I'm kind of this gap between the two, where I'm modeling it and I'm analyzing common diagnostics that are used and trying to say, at higher resolution, what's the physical reason there's turbulence and how are the diagnostics doing at replicating that phenomenon. Blue Waters has the same resources, and it's a really good opportunity to learn a new supercomputer. It was a good fit for my project. You need high-resolution simulations, especially for thunderstorm type projects, and it was a great place to get those computational hours that I needed. So the Blue Water support team was very important for my research, and their help was always positive. Without their help, I would not have been able to compile the model and really wouldn't have had a project. My work definitely impacts society at large. I've done 6 high-resolution simulations of different convective types in different regions. Not enough to go to the FAA and say, this is what we should do with this information, but it's a stepping stone saying, okay, there is a difference in how turbulence looks around these storms in different regions. We need many more simulations to put that on a statistical term, and then we can translate that into policy. The goal would be, hey, pilot, you're flying into an environment where you're going to see a mesoscale convective system. You need to be 50 miles away from it, not 20. Fly to the north, fly to the south, but avoid the east or the west because you'll have a higher probability of turbulence. So in the end, it's more efficient for fuel consumption for aircraft and routing policies. Because of Blue Waters, I was able to analyze at high resolution thunderstorms and look at turbulence that is produced from these thunderstorms, and hopefully we'll be able to help aviation avoid turbulence.